lot of discussions and deliberations are taking place across the globe on the issue of global warming and its long-term consequences on climate changes. Global warming is a phenomenon of disastrous consequences. From the last 2-3 decades, the entire world has been talking about global warming, but global effort to check this phenomenon is still preliminary and inadequate. Greater evaporation, untimely melting of ice caps, sea level changes, coastal inundation, etc. have been reported. As revealed by US satellite, 125 Siberian lakes have been disappeared and 2 large lakes have shrunk. The chain of events caused by global warming has impact on world economy, and the developing countries like India are worst affected. So let us know what actually the meaning of greenhouse effect. Earth absorbs incoming solar radiation and then tries to cool by emitting long wavelength infrared radiation. The radiation is absorbed by greenhouse gases and hence they cannot escape. The net effect should be to increase mean annual temperature. Some of the important greenhouse gases are carbon dioxide, that is burning of carbon based fuels, methane, anaerobic bacteria in rice field, cows, sewage which constitute 4 to 9%, nitrous oxide, that is fossil fuel and fertilizers, chlorofluorocarbons otherwise called CFCs due to refrigeration and spray cans, and ozone O3 which constitute 3 to 7%. Greenhouse gases are absorbed by infrared radiation, which in turn much of the energy is re-radiated to the surface and lower temperature. The mechanism is named after the effect of solar radiation passing through glass and warming a greenhouse. In greenhouse, it retains heat and fundamentally by reducing airflow, isolating the warm air inside the structure so that it is not lost by convection. Joseph Fourier, who is a pioneer, a French mathematician, discovered the greenhouse effect in 1824, first reliably experimented on by Irish physicist John Tyndall in 1858, and first reported quantitatively by Swedish scientist Steve Arrhenius in 1896. In the atmospheric greenhouse effect, sunlight encounters forests, grasslands, ocean surfaces, ice caps, deserts and cities all absorb, reflect and radiate radiation differently. Sunlight falling on a white glacier strongly reflect back into the space, resulting in minimal heating of surface and lower temperature. Sunlight falling on a desert soil is strongly absorbed and contributes significantly the heating of the surface and lower atmosphere. Cloud cover also affects greenhouse warming by which reducing the amount of solar energy reaching the Earth's surface and by reducing the amount of radiation energy emitted into space. Real greenhouses. Greenhouses effect are named analogy to greenhouse. The major difference between greenhouse effect and greenhouses is that the heat retained are different and both limit the rate of thermal energy flowing out of the system. Through convection, that is sensible heat support, the absorbed heat is not allowed to leave the greenhouse. Greenhouse gases absorb the outgoing radiative energy, and greenhouse gases affect the heat of Earth and re-emit some of it back towards Earth. The greenhouse is built by means of glass or plastic, which allows the sunlight to pass through it. Primarily, the sunlight heats the ground surface inside, which then warms the air in the greenhouse. The air within the greenhouse continues to heat since it is confined within the greenhouse, and in the atmosphere, warm air near the surface rises and mixes with the cool air aloft. This can be demonstrated by opening a small window near roof of greenhouse. The temperature will drop considerably. Thus, greenhouse work primarily by preventing convective cooling. In the greenhouse effect, rather than retaining heat by physically preventing the movement of the air, greenhouse gases act to warm the earth by re-radiating some of the energy back towards the surface. Greenhouse effect is brought about by several gases, and these gases, namely carbon dioxide, methane, nitrous oxide, chlorofluorocarbons, and tropospheric ozone. Carbon dioxide plays a major role and accounts for about 55% of change in the intensity of greenhouse effect. Chlorofluorocarbons contribute 25%, 15% by methane and 5% nitrous oxide are produced respectively. The role of ozone towards enhancement of greenhouse effect is yet to be quantified. In the year 2005, the average concentration of carbon dioxide were about 380 parts per million, that is expressed in ppm. Prior to 1900, the carbon dioxide concentration was about 280 ppm. Due to increased urbanization and industrialization, the carbon dioxide concentration has enormously gone up, which is entering the atmosphere. The main reason for emission of carbon dioxide is due to burning of fossil fuel, combustion for transportation, generation of electricity, space heating and cooking, deforestation and destruction of biodiversity. Emission due to fossil fuel combustion accounts for 65% extra carbon dioxide now found in atmosphere. The remaining 35% is derived from the conversion of prairie woodland and forested ecosystem primarily into agricultural ecosystem, which can hold 20 to 100 times more carbon dioxide per unit area than agriculture system. Chlorofluorocarbons are artificially created are the strongest greenhouse gases. These gases are also known to make holes in the ozone layer, which has far-reaching effect on the human beings. General decline in global stratospheric ozone levels over the last 2 decades has caused many nations to cut back on their production and use of these chemicals. As per the Montreal Protocol Agreement, by 46 nations established a pact and immediate timetable for the reduction of chlorofluorocarbons production and its use. The average concentration of nitrous oxide is one of the important greenhouse gas, is increasing 0.2 to 0.3 μm per year. The important reason for the increase is due to biomass burning, land use conversion, fossil fuel combustion and soil fertigation. Nitrous oxide is also produced due to conversion of savanna and grassland ecosystem to agriculture field. These processes reduce the amount of nitrogen stored in living vegetation through decomposition of organic matter. When biomass and fossil fuels are burnt, nitrous oxide is released into the atmosphere. Extensive usage of nitrate, ammonium fertilizers to enhance the growth is another source of nitrous oxide. It is difficult to determine the role of ozone in the atmosphere. Concentration of ozone gas are found in two different regions of Earth's atmosphere. Majority of ozone, that is about 97%, found in the atmosphere is localized in stratospheric at an altitude of 15 to 55 kilometers above the Earth's surface. Of late, the concentrations of stratospheric ozone has been decreasing because of buildup of chlorofluorocarbons in the atmosphere. Since the late 1970s, scientists have discussed that total column ozone present over Antarctica in the springtime have decreased as much as 70%. Ozone is highly concentrated at Earth's surface, and most of this ozone is created as an artificial byproduct of photochemical smog. Green concentration, that is different concentrations of the greenhouse gases, are given here. Carbon dioxide, that is carbon dioxide 280 ppm in 1750, and in 2003 it has been increased to 376 ppm, and the percent change is 34%. Methane, it was just 0.71 ppm in 1750, has considerably increased to 1.79 ppm, and the net percent change is 152%. Whereas nitrous oxide, it was 270 parts per billion in 1750, has gone up to 319 parts per billion, increasing by 18%. Chlorofluorocarbon in 1750, but now it is increased to 880 parts per trillion, and net change is, percent change is not applicable here. And of course, ozone, it was unknown in 1750, and in 2003 it varies with latitude and altitude. Most of the radiant energy from the sun is concentrated in the visible and near visible part of the spectrum. Visible light, which represent 43% of the total radiant energy emitted, lies between 400 to 700 nanometer of the narrow band of visible light. Wavelength shorter than visible account for 7 to 8% of the total, but are extremely important because of their high energy per photon. Shorter the wavelength of light, more energy it contains. The ultraviolet light is more energetic. The remaining 49 to 50% of radiant light is spread over the wavelength longer than those of visible light. Most of the thermal radiation is absorbed by the atmosphere and re-radiated both upwards and downwards. That the rays that are radiated downwards is absorbed by the Earth's surface. This trapping of long wavelength thermal radiation leading to a higher equilibrium temperature. The incoming radiation from the sun is mostly in the form of visible light, and nearby wavelengths largely in the range of 0.2 to 4 micrometers, corresponding to the sun's relative temperature of 6000 K. Half of the radiation is in the visible light to which our eyes are adapted. Earth surface absorbs 50% of sun's energy, and rest is reflected or absorbed by the atmosphere. The absorbed energy warms the surface, and surface of the earth is warmed to a temperature around 255 K, which radiates long wavelength infrared heat in the range 4 to 100 micrometers. At these wavelengths, greenhouse gases are transparent to incoming solar radiation and are more absorbent. Increasing the concentration of gases increases the amount of absorption and re-radiation, thereby further warms the layers and there is ultimately the surface below. Several effects of global warming, including steady sea level rise, increased cyclonic activity, changes in ambient temperature and precipitation patterns, have affected or projected to affect the subcontinent. Projected global average surface warming result in temperature which increases worldwide at the end of 21st century, which ranges from 0.6 to 4 degree centigrade. Rise in sea level. At the end of 21st century, there is considerable increase in sea level from 0.18 to 0.59 meters, which results in the submerging of several low-lying islands in the Sundarbans, displacing thousands of people. Environmental. Landslides and flooding are projected to have an impact on states such as Assam. Ecological disasters such as coral bleaching event that killed more than 70% of corals in the reef ecosystem of Lakshadweep and Andamans. This is brought by elevated ocean temperatures tied to global warming and also projected to become increasingly common. Economic effects are, according to Indira Gandhi Institute of Development Research, which has reported that climate-related factors could cause India's GDP to decline by up to 9%, and because of this reason would result in shifting growing seasons for major crops such as rice, and production of which could fall by 40%. About 7 million people will be displaced due to submersion of parts of Mumbai and Chennai if global temperature were to rise by a mere 2 degree centigrade. Some of the social changes or events projected are: climate change in India will have enormous impact on more than 400 million people because many depend on natural resources for food, shelter and income. More than 56% of people in India work in agriculture, while others earn their living in coastal areas. Pollution's effect are burning of biomass in northwestern India and air pollution from industrial cities in North India, which concentrate inside the Ganges basin. Black carbon and dust which are blown towards the higher altitudes by winds at southern faces of Himalayas can absorb shortwave radiation and heat the air over Tibetan plateau. Glaciers in India. Glaciers act as sensors of climatic change. Out of the 3% fresh water available on Earth, 67% is stored in glaciers and ice caps. It is estimated that Himalayas alone contribute 30 to 40% of water to the Ganges, which is particularly critical in dry season prior to monsoon rains in India. Glaciers are result of continuous snowfall over long period of time that compresses into large thickened ice masses. As per the latest report provided by the Geological Survey of India, Government of India, that Himalaya contains 9,575 glaciers distributed in the Jammu and Kashmir, Himachal Pradesh, Uttarakhand, etc. Gangotri Glacier is alone more than 30 kilometers long and covers an area of about 148 square kilometers. Then the effect on deserts. Global warming causes higher temperature and less rainfall overall. This problem is commonly seen in desert biomes because the soil dries out, particularly the layer of topsoil that holds the most nutrient. This makes it easier for dust storms to sweep the nutrient-rich topsoil and carry it to other areas, which will prevent plant life from thriving and disrupt the entire ecosystem. In addition to dust storms and during monsoon, rainfall wash away the topsoil and potentially flood the area. Since the ground is so dry, the water which cannot soak fast into the soil as well. Hurricanes, flood, tsunamis and wildfires are becoming common, and as a consequence of these destructive events escalate in 21st century. Due to global warming, higher wind speeds are recorded, so also the increased ocean temperatures. These in turn increase the frequency of cyclones. Alarming rise in the sea level due to greenhouse effect. Polar ice caps are melting at a faster rate. Some experts believe that Arctic could be ice-free within 5 years, which result in the rising of sea levels by 7 feet worldwide. Diseases and fungi attack crops, lowering the quality and production. Natural disasters will destroy existing crops. Once abundant food may disappear or become expensive. Human beings won't be able to eat healthy food. Uncontrollable epidemics are on the rise. United Nations projects 2.11 billion people will face severe water shortages by 2025 if the consumption continues at current rate. Electrical power production likely to be limited by water shortages. Despite energy efficiency trends, total energy consumption will rise by about 50% over the period 2005 to 2025. It is predicted that there is likelihood of 190 gigatons of greenhouse gases into the atmosphere. Greenland's coastal lands projected to rise at a rate of 2 inches per year due to melting of Greenland's ice sheet. Future research should aim at combating the evils of global warming to use alternative source of energy and evolving new methods to reduce pollution. Otherwise, this will take a lot of toll year after year due to the incidence of incurable diseases.